The question is to find a subarray whose product is less than k. Not only its product should be less than k, but the subarray should be contiguous. What do you mean by this? We mean that, let's say we have, for example, an array and our k would be, so we need to find a contiguous subarray whose product would be less than k. So 1 less than k. 1 multiplied, the product, remember, 1 multiplied by 3 less than 4. Okay. 1 multiplied by 3 by 1 is less than 4. But 1 multiplied by 1 is not okay because it's not contiguous. It's having 3 separating. It's not a contiguous subarray. So a contiguous subarray is either this one, or these 2, or these 3, or these 4, or these 2, or these 2, or these 3. Okay, this is a contiguous subarray. Now I want to tell you that this problem is related to many other problems. So when you hear of this problem, bell should immediately ring, and you should remember we are dealing with subarrays. We are dealing with a product. So I can devise many questions. What is the subarrays whose sum is equal to k, whose sum is less than k, contiguous subarray, non-contiguous subarray? Okay, so you can devise many questions like this, and once you get one of them, you can get the others pretty easily. Another thing to remember is that you always have all the possibilities open: brute force, recursion, and iteration. So let's first try with the brute force. When we try this kind of sub-problems, let's write again the array. Then we have this array. You need to scan and to find all the subsequence. How do you do this? Well, you need 2 pointers: start index and end index. Okay, once you have a start and an end, or S and E, okay, start and end index, you point one of them to the start, then the end will increase, but it will start also from the beginning, but the end will continue, and so will the start. But first the end will move on until the end, and then the start will move on to this one, and you get this subarray, then this and this subarray, then this and this subarray, and this will move on. Okay, and you get like this all these subarrays. When the end is here and the start is here, you get only these two, so you get all the permutations inside. So remember, we needed the start, we needed the end somewhere, or the start would be here and the end would be here, and then we need another index to scan in between them. If you write this as a for loop, what you get is for start, which starts at 0 until the end, until the size of the array. Then you have a nested for loop. Now this is a pattern when you need to find a subsequence with brute force. You have another sub for loop or nested for loop with the end index moving forward, starting from 0, and you have another for loop. Now that you have defined where is my beginning is here, my end is here, and I'm moving them both. Now you need to actually move in between them. So you have another just index. As we have 3 nesting of for loops, the complexity of this would be an O of n power of 3. This is not good. This is not a good complexity, and many times if you do iteration, then the complexity could be an O of n. So this is what we want. We want to find if we can improve this. Now, one way to think if we can improve this algorithm is by noting that what did we do that we do not really need to do, or we repeated in the brute force solution. So in the brute force solution, we actually found the subarrays, but they didn't ask us to to find the actual subarrays. All the question said is find how many contiguous subarrays whose product is less than k. Okay, how many of those? And this is a big clue. You should note the notation of the question. If it's just asking how many, it's a simpler problem. Maybe not simpler, but it requires maybe a less effort. It should be a hint for you that you don't need to find the subarrays. And if we had O of n 3 to find all the subarrays, maybe we can do better. So how can we do better? Let's think about it. I recommend you to pause the video and think about it, and if you have an answer or need a hint or to continue, then to unpause. So let's continue, and now we will move on with finding how can we do better with the O and 3. We can do better because we should notice that this is okay. We said that the first item is okay, its product with itself is less than k. Now we move on and we have the next item. How many items, if this item is okay, the product of it by 1 is okay, how many subarrays do we have here? Here we have only additional 2, and the 1 we already used, so we have these 2, and we have 2 and 1 together. So note what we have here. We have the new item that we scanned and the 2 items. Let's see what happens when we move on to the third one. So our start index is here and our end index is here. Okay, so we have a new item which corresponds 1 is less than 4 if k is 4. 1 is less than 4. So we have one item here. We have an additional one here. So this is the second one, and we have an additional one here. These 2 guys we already counted. So note the pattern. Whenever we move on the end index forward and we moved it forward, we have an additional set of contiguous items, which is simply the number of items from the start to the end index. You see our start and end index is here. We have an additional 3 numbers, so it's the end index, which in this case is 2, minus the start index, which is in this case is 0, plus 1. So we have an additional 3 items. Okay, let's do this exercise a little bit more. One more time. So I'll put here just 1 and here 3. So let's say our start index is here, our end index is here. So we have an additional item here, an additional one here, an additional one here, and an additional here. So this one corresponds to this, to this, to this, and to this. So we have 4 items. It's the end index 4 minus the start index 1, which is 3, plus 1. You always just add 1 and you get 4 new results. Now you might ask, what about these 2 guys? They are like in the middle, but you included them. You included them when you had the start index at this index, 0 index, and the end index at index 2. So you already included them. So the formula is just to have a start index, and then to have the end index moving forward, and then you need to check whether the global product is still less than k. If it's still less than k, just add the amount of items that you had, 4. Okay, you just add 4, because this is the new amount of items that contributed. Now let's move on by writing the code for that. So the code for that would be as following. We get into the input of the function, we get the array, and we get k. Okay, first we do a termination check. What if k is less or equal to 1? Okay, if k, we said that the array is a positive integers. As it's positive integers, it's only 1, 2, 3. So if k is less or equal to 1, then the only way that the array would have any item less than k would be if the array contains 0. But we said we want items less than k, not less or equal, so we simply return 0 because all the items are larger than 0 and are positive items. Next we initialize, so we have the left index to initialize, we have the global product to initialize, and we have the global answer, the how many products we have, and we have the right index to initialize. So let's initialize them all. The total is sorry, it's 0. The product, so that when we multiply, the product is 1, so when we multiply at least by 1 and not by 0. And the left index would be 0. Now we start looping. We start looping via an index which will run from left to right. Because it's running from left to right, it's going to be the right boundary. Remember that we said that we have this, okay, and we have a left index, and then we increment the right index, then we increment again the right index, and we increment again the right index, and when the product does not satisfy less than k, we increment the left index in the hope that the smaller subset would satisfy the less than k. So the way we do that is as following. We let the left index is already at left, nothing to do with it. We first want to try and run the right index. The left index is already at the right place, let's say it's place 0. We need now to run the right index. So let's run the right index forward and count the number of items we have. So we have 4. The right index starting from 0. The right index goes until the end, so right until the end of the array.length, and we increment by 1 each time. Okay, now we have the left index on index 0, the right index on index 0. Let's see how much the product is as of now. So the product would be the current product times the array and the right side of the index. If the product is smaller than k, then remember that at this point what we wanted to do is to count the number that we have. So here we have 0, index 0 minus 0 if the left and the right here at the same point, which is our state right now. Left and right are at 0, so 0 minus 0 plus 1, so we have 1. Okay, and then we move on with the right index. And when do we move the left index? We are going to move it when our product is bigger. So let's code this. So if our left index is, if our product is larger than k, we need to move the left index, because if we won't move the left index, our product will keep getting bigger and bigger. So we start by this. Although this is not that intuitive, we first put this condition in order to avoid two conditions. So we put while the product, just by any case, the product is larger or equal than k, then what we do in this case, we move the left to the right, we move the left side to the right, and while we do that, we divide the current product by the current array. I know this is a little bit too complex, but try to bear with me. Left. Okay, so let me repeat again. Okay, so what we did here is we had two indexes standing. Let's say they began from 0, left and right. Both are pointing to 0. Now, in the good case, where the product of one by itself is less than 4, then in this case we add 1 to the total. How do we add 1? Remember, we said we are counting the items, so it's going to be 0, the index 0 of the right minus the index 0 of the left, plus 1. This is simply counting number of items between two indexes. That's it. That's all. But if the product is larger than k, we must move the left forward. It won't help if we move the right forward. We will skip items. We must move the left. As we are moving the left forward, we are getting rid of the current left item it's pointing to. So we are dividing the product. Once we finish with this for loop, this means that now the product is less than k. As the product is less than k, we do total, which is we are incrementing it by the number of items between the two indexes. How do we know what is the number of items between the two indexes? Well, it's simply the right index minus left index plus 1. This is it. If you have two indexes, you need to know the number of items, and we explained before why it's simply the number of items. Then the number of items between the right and the left side is right minus left plus 1, and we end our for loop. Now, what is the time complexity of this loop? Well, you have this loop, and this loop starts from the left and goes simply until the end. So it's from this loop is O of n, and here we have like another loop like while, so we could say O of n power of 2, but it won't be n of power of 2, because in this inner loop left could be increased only from 0 to k, and when it's being increased, it's not causing another iteration of the loop. It's simply being increased. At most times, the left would be increased n times. And if you want to look at it visually, then if you have this, then you have the left and the right pointing to it. The right is moving forward, moving forward, moving forward, moving forward. You see, it's only moving forward. It's not moving backward. And the left is also only moving forward. So both are just moving forward. So it's both O of n. And this solution is an O of n. Now, what do I want you to learn from this exercise? I want you to learn multiple things. First, that in order to scan like this an array, you need a left index and a right index. The brute force of 3 for loops is O of n to the third to 3. And the next item I want you to learn is that when you have a question, the question did not ask you to find all sub-arrays. It just ask you to find the number of sub-arrays. Then in this case you should think whether it's a simpler solution, and we saw that it's a simpler solution because if we have multiple items, left is here and right is here, this is index 0, 1, 2, 3, then the number of items you can calculate it without going with the indexes to the left and the right. It's simply a 3, which is this index, minus 0 plus 1, which is 4. So we have here 4 items, and indeed we have here 4 items. So thank you for listening. I hope you enjoyed it, and I'll see you in the next episode.